Imagine the sound of 1,000 freight trains rushing toward you. But instead of steel and iron, it is a wall of liquid earth, massive boulders and uprooted redwoods charging down a mountainside. This isn't a nightmare. It is the current reality for one of the most beautiful places on Earth. As we speak, a massive flood emergency is expanding across California, and the iconic Highway 1 has suffered a catastrophic collapse, leaving the community of Big Sur effectively buried and cut off from the rest of the world. The ground isn't just saturated, it is liquefying. As atmospheric rivers continue to pummel the Golden State, geologists are witnessing a transformation of the landscape that defies modern engineering. Today we are going deep into the heart of this disaster to understand the incredible scientific forces at play. We will look at why the Santa Lucia Mountains are literally disintegrating, the terrifying mechanics of the Rocky Creek slip, and how recent scientific discoveries about soil mechanics are revealing that California's most famous drive might be facing a permanent change. The images coming out of Big Sur right now are haunting. A massive hunk of the southbound lane near Rocky Creek has simply vanished into the Pacific Ocean, leaving a jagged void where thousands of tourists usually marvel at the view. When we talk about a highway collapsing, it's not just about a few potholes or a bit of debris. We are talking about the utter failure of the mountain's structural integrity. For the residents of Big Sur, this is a recurring nightmare that has reached a new level of intensity. They are used to being isolated, but this time the scale of the mudslides and the depth of the road failures suggest that the very foundation of the coast is undergoing a fundamental shift. But what is the science behind this disaster? To understand why Big Sur is falling into the sea, we have to look at the unique geology of the California coast. This region is a tectonic battlefield. The mountains here are being pushed up by the collision of plates. These are essentially rivers in the sky, carrying as much water as the mouth of the Mississippi, but in the form of vapor. When these moisture plumes hit the steep rise of the Santa Lucia Mountains, they dump astronomical amounts of rain in a very short period. This leads to a process known as pore water pressure. Imagine the soil like a sponge. A little water makes it firm, but when you flood it, the water pushes the soil particles apart. At a certain point, the internal friction that holds the mountain together disappears, and the entire mass starts to behave like a liquid. This is how a solid hillside becomes a mudslide that can bury entire sections of a highway in seconds. The collapse at Rocky Creek is particularly fascinating from a geological perspective. Engineers have discovered that the slide isn't just on the surface. It is a deep-seated failure. The water has penetrated so deep into the coastal bluffs that it has reached an ancient layer of slippery clay. Once that layer becomes lubricated, the thousands of tons of rock and soil sitting on top have no choice but to follow the path of gravity. Scientists are using drone technology and LiDAR, which stands for light detection and ranging, to peel back the vegetation and see the true face of the mountain. What they are finding is a network of cracks that suggest the entire shelf of the highway is moving toward the ocean. As the flood emergency expands, the logistics of the situation are becoming a Herculean task for Caltrans and emergency responders. Over 1,600 people were trapped in Big Sur when the road gave way. This isn't just a matter of waiting for the rain to stop. How do you feed a community when the only road in and out is gone? How do you provide medical care? We are seeing a massive air bridge operation, and temporary convoys being guided across the remaining northbound lane with extreme caution. But every time the wind picks up or another band of rain moves in, the work has to stop. The mountain is still alive and moving, and any vibration from heavy machinery could trigger a secondary collapse. The human element of this crisis is profound. Big Sur is home to artists, hikers, and families who have lived there for generations. They have a resilience that is tested every year. But this year feels different. The frequency of these 1,000-year storm events is increasing. Recent scientific discoveries and climate modeling suggest that California is entering a period of weather whiplash, moving from extreme, multi-year droughts to violent, record-breaking floods. This whiplash is the worst possible scenario for soil stability. During the drought, the ground cracks and the vegetation that holds the soil together dies or becomes dormant. When the floods hit, there is nothing to hold the earth in place. The soil is effectively raw, ready to be washed away by the first heavy downpour. Moreover, we have to talk about the role of fire. California's devastating wildfire seasons have a direct impact on these mudslides. When a forest burns, it creates a hydrophobic layer in the soil, a waxy surface that prevents water from soaking in. Instead of the mountain absorbing the rain like a giant sponge, the water runs off the surface, with incredible speed gathering debris and turning into a debris flow. These aren't just mudslides. They are avalanches of rock and wood that act like a liquid sandpaper, scouring the canyons and taking out everything in their path. The Big Sur area has been hit by multiple fires in the last decade, leaving the slopes vulnerable and ready to fail. Geologists monitoring the site are using some of the most advanced technology available to track the movement. They have installed extensometers, sensors that measure how much a crack in the road is widening in real time. Even more impressively, they are using satellite-based interferometry to detect shifts in the Earth's crust as small as a few millimeters from space. By analyzing this data, researchers can see the pulse of the mountain. They can tell if the slide is accelerating or if the drainage efforts are working. This is the cutting edge of disaster management, using a digital twin of the coastline to predict where the next failure will happen before it does. But even with the best data, the engineering challenges are mind-boggling. How do you fix a road when there is no ground left to build it on? Caltrans has used bridge-to-nowhere designs, where they build a bridge over a recurring slide area, anchored into the stable rock deep inside the mountain. The stable rock is getting harder to find. The entire coastal terrace is showing signs of instability. Some scientists are raising a radical question. Is it time to give up on parts of Highway 1? This is a controversial idea given the highway's cultural and economic importance, but the geological reality might eventually force our hand. We are seeing a conflict between 25th century infrastructure and 21st century environmental reality. The economic impact of the Big Sur closure is staggering. This region relies almost entirely on tourism. With the highway severed, hotels, restaurants, and galleries are seeing their bookings vanish. But it goes beyond just money. Highway 1 is a lifeline. It is the way children get to school, and the way the sick get to the hospital. The buried community of Big Sur is a reminder that even in one of the wealthiest states in the world, we are still deeply vulnerable to the power of the natural world. As we look closer at the scientific discoveries made during this emergency, a concerning picture of the deep coast emerges. Researchers have found that the base of these coastal cliffs is being undercut by increasingly powerful Pacific swells. As sea levels rise, the energy of the ocean is hitting the cliffs higher up and with more force. This creates a toe failure. The bottom of the cliff is washed away, leaving the top heavy and unsupported. It's like pulling the bottom block out of a Jenga tower. The mudslides we see on the surface are often just a reaction to what the ocean is doing at the base. This is a dual threat system. A sky river pouring water from above and a rising ocean carving from below. The evacuation efforts have been a logistical masterpiece, but they are fraught with danger. Pilot cars lead small groups of vehicles through the remaining sliver of road during brief periods of calm. The drivers report feeling the ground shiver beneath their tires. The sound of the Pacific crashing against the debris hundreds of feet below is a constant reminder of the stakes. This is geology in the fast lane. Usually we think of geological changes happening over millions of years. But in California, 1,000,000 years of change can happen in a single weekend. Some researchers are looking at how specific types of deep-rooted native plants can be used to stitch the soil back together. However, the sheer volume of water in these atmospheric rivers is often too much for any plant to handle. We are seeing redwoods, trees that have stood for centuries, being tipped over like matchsticks, because the very ground they are rooted in has turned to soup. It is a sobering sight that reminds us of the scale of this emergency. The true origin of the mudslide problem in California is also a story of historical land use. Over a century ago, when the highway was first carved into the cliffs, engineers didn't have the understanding of paleo-slides that we have today. Many sections of the road were built right on top of ancient landslide deposits, earth that had moved thousands of years ago and was technically at rest but not truly stable. By cutting into these slopes to make a flat roadbed, we essentially reawakened these sleeping giants. Modern science is now showing us that we are often fighting against a history of movement that predates human arrival on the coast. Is there a solution? Geotechnical engineers are looking at gravity walls and soil nailing, where long steel rods are driven 40 or 50 feet into the mountain to anchor the road. They are also looking at horizontal drains, perforated pipes drilled into the hillside to bleed out the water before it can build up enough pressure to trigger a slide. These systems are being deployed at Rocky Creek as we speak. But the mountain is vast, and the rain is relentless. For every gallon of water drained away, the atmospheric river is dumping 10,000 more. This situation in California is a global case study for coastal communities, from the Amalfi Coast in Italy to the Great Ocean Road in Australia. The combination of rising seas and more intense rainfall is putting historic infrastructure at risk. The Big Sur emergency is being watched by scientists worldwide. They are learning how to manage cascading disasters, where a drought leads to a fire, which leads to a flood, which leads to a landslide. Understanding the link between these events is the key to surviving the coming decades. The psychological toll on the residents is something that science is also beginning to quantify. Living in a state of constant vigilance creates an enormous amount of stress. People in Big Sur have go bags packed year-round. They listen to the rain not as a soothing sound, but as a potential threat. This eco-anxiety is a real health issue that comes along with the physical destruction of the land. We are seeing the emotional landscape of California shift just as much as the physical one. Looking ahead, the recovery will take months, if not years. But even when the road is patched and the debris is cleared, the underlying problem remains. The Santa Lucia Mountains are moving. The Pacific Ocean is rising. And the sky is getting wetter. This isn't a one-time emergency. It is a new state of existence for the California coast. We are witnessing the great reshaping of the West. The resilience of the human spirit is the only thing that matches the power of the storm. Even as the highway collapses, neighbors are checking on each other. Volunteers are organizing supply drops. There is a deep love for this rugged coast that keeps people there. Despite the danger, they understand that the beauty of Big Sur is inseparable from the forces that are currently tearing it apart. The same tectonic energy that created these stunning cliffs is the energy that eventually pulls them down. You can't have one without the other. As the flood emergency continues to expand, other parts of the state are also on high alert. The Central Valley is facing levee failures, and the Sierra Nevada is dealing with a rain-on-snow event that could trigger massive flooding downstream. California's water management system, designed for a climate that no longer exists, is being pushed to its absolute breaking point, and the results are being written in mud and water. The scientific community is calling for a managed retreat in some areas, moving critical infrastructure away from the most dangerous zones. But how do you retreat from Highway 1? It is a national treasure. The debate is getting heated. Some advocate for massive multi-billion-dollar tunnels through the mountains to bypass the slide zones, while others suggest a more humble approach, accepting that the road will be closed for parts of every year and building better local self-sufficiency for the communities. What can we do as observers? First, we need to respect the power of these events. If you see a road closed sign in California during a storm, it's not a suggestion. It is a warning based on the terrifying physics of soil saturation. Second, we need to support the scientific research that helps us predict these events. The better our sky river forecasting becomes, the more lives we can save. Every hour of warning gives a family time to evacuate and a road crew time to clear a drain. As the sun sets over the Pacific, the silhouette of the broken highway at Rocky Creek is a stark reminder of our place in the world. We are guests on a very active, very powerful planet. The mudslides burying Big Sur are not a freak accident. They are the natural result of geology and climate performing their ancient dance. Our job is to learn the steps of that dance, so we can stay out of the way when the music gets too loud. The California flood emergency is a story of water, earth, and human endurance. It is a story that is far from over. As another atmospheric river looms on the horizon, the people of Big Sur are bracing for the next round. They are watching the mountain. They are listening to the rain. And they are waiting for the earth to stop moving. But until it does, the scientific world will be there, documenting every inch of the slide, trying to unlock the secrets of the mountain so we can protect the beauty of the coast for the generations to come. Recent discoveries about slow-moving landslides are also giving us hope. Scientists have found that not all slides result in a sudden collapse. Some move just a few inches a year. By identifying these slugs of earth, we can proactively stabilize them before they become emergencies. The data gathered at Big Sur today will help create better models for these slow slides everywhere. We are turning a disaster into a library of knowledge. The true origin of our ability to live on this coast is our willingness to adapt. Highway 1 has been rebuilt hundreds of times since it opened in 1937. Each time we build it a little stronger, a little smarter, But this year's collapse at Rocky Creek is a reminder that we might need a whole new way of thinking. Maybe the road of the future isn't a road at all, but a more flexible connection to the land. So does our imagination of what is possible. As we conclude this deep dive, keep the people of Big Sur in your thoughts. They are the guardians of a magical place, and they are currently on the front line of a changing world. The mud might bury the road, but it can't bury the spirit of the community. Stay tuned as we monitor this developing situation and the incredible scientific discoveries that are emerging from the mud and the flood. California is a land of extremes, and today we are seeing just how extreme it can get. The floodwaters will eventually recede. The mud will eventually dry. But the lessons we learned during this emergency will stay with us forever. We are learning how to live on a planet that is constantly in flux. We are learning how to build our lives around the cycles of the sky and the movements of the earth. It is a challenging journey, but it is the one we are on. The Big Sur highway collapse is more than just a headline. It is a chapter in the ongoing story of humanity's relationship with the natural world. So the next time you think about the Golden State, remember that underneath the sunshine and the surf, there is a complex churning geological engine that never sleeps. The mudslides are the exhaust of that engine. The floods are its fuel, and we are the passengers, trying to find a safe way through the fog. Highway 1 will hopefully open again, but the mountain will never forget the rain, and we should never forget the power of the earth. In the heart of the crisis, every sensor and every scientific observation counts. We are building a future where we don't just react to disasters, but we anticipate them. We are moving from a world of fixing to a world of flowing. The science of the Big Sur mudslides is a vital piece of the puzzle. Let's hope for a calm sky and a stable ground for the people of California. The emergency is real, but so is our resolve to understand and overcome it. The story continues, and we will be there to bring you every new discovery and every update from the coast. Stay safe, stay curious, and keep an eye on the mountain.